Hey guys, I believe that we've taken the lecture, which is lecture 4, and lecture 4 was on dihydroxylation reactions of alkene. So in this lecture, we are going to talk about the epoxidation of alkenes. Now, we said that this is one of the methods of introducing oxygen into the alkene double bond. Now, at the end of this lecture, what are you expected to know? Now, you are expected to know how to determine the oxidizing agent used and the product of epoxidation of alkenes. So let's dive right into what we have for this lecture. Now, what are epoxide? That's the first question you ask yourself. What are epoxide? Now, as name imply, epoxide, they are cyclic ethers. So I'm going to take this. They are cyclic ethers. So epoxide, they are cyclic ethers. Now, another characteristic of epoxide is they are three-membered ring. Three-membered ring. So having analyzed it in this form now, can we now say that epoxides are three-membered ring cyclic ethers? Now, what are ethers? We said that ethers are functional groups that have the general formula of RO, OR. So what we mean by cyclic ethers, three-membered, we have something like this. For the epoxide, it will be something like this: RO, O, let's say RO, with this one like this. Are you getting it now? So that is it. Now, this is the general form of all ethers, and this is the general form of the epoxide, which are the cyclic ethers. Now, if you want to be very close to what the structure actually look at or look like, you have something like this. It's going to give us, let's say, CH come on, let's say you have CH2, and then you have the oxygen, and then this, and then you have RO. These are what we call the epoxide. Now, another name for the epoxides are oxidants. Another name for the epoxides are the oxidants. And what are their usefulness in organic synthesis and in pharmaceutical practice? Now, the epoxides, which are also called the oxidants, they serve as synthetic intermediates. They serve as what? Intermediate. Let's say a bridge. Intermediate, a bridge that converts alkene to other functional group. So if we want to represent it diagrammatically, we can say that this is alkene, and then we have a bridge here, and then we have other functional group, right? The question is, what are those things that are present in this other functional group? This is what we call the epoxide or the oxidants. They are intermediate. So it means that if you want to convert alkene to other functional group, first of all, you convert them to epoxide. Then from epoxide, you can now convert them to whatever functional group you want to convert them to. All right? Now, having looked at this, how are epoxide made, or how do we actually convert alkenes to epoxide? Now, alkenes are converted to epoxide via a peroxide. So whenever we have an alkene, let's say this is an alkene, double bond, plus a peroxy acid, or let's say a peracid, or you can call them a peroxy acid, is going to give us the epoxide plus a carboxylic acid functional group. Now the question is, what is a peracid? A peracid is a carboxylic acid with one more oxygen, more than the normal oxygen, or more than the normal carboxylic acid. Sorry, what am I saying? I said that the epoxide, the peracids are carboxylic acids, but they have one more oxygen, more than the normal carboxylic acid. So if you have, let's say acetic acid is RCOOH. Now peroxyacetic acid will be RCOOH. Are you getting it? Which can be represented structurally as, normally this is RC double bond O, and then you have OH. This will now be RC double bond O, and then you have OOH. This is peroxy or peracetic acid. Let's take it like that. This is peracetic acid, which is a peracid or a peroxy acid. So that you call them peracid or peroxy acids. Now, having looked at this, how are these peracids formed? Let's come here. Now, the peracids are formed by reaction of the corresponding acid with hydrogen peroxide. So the acid here in this case is acetic acid. So if you react acetic acid with hydrogen peroxide, you are going to form a peracid, which is peracetic acid, which is something like this. C, you know there's a C there, then we have OOH. So what would I call this product? I will naturally call this product peracetic acid. Right? Now, no, this is C. This is formic acid, because this is just HCOOH, right? So this is formic acid. So you call this performic acid. Right? Now, this one is called acetic acid. If you react it with hydrogen peroxide, then in this case you are going to form peracetic acid, which is CH3 C double bond O OH, and then we can call this peracetic acid. When you say per, it means one more than, hyper, one more than they require. Are you getting it now? Now this is benzoic acid on a normal note. Benzoic acid. Now if you react it with hydrogen peroxide, it's going to give us perbenzoic acid, which is something like this. This is the normal benzene ring, and then I have this, and then I have O, and then OH, and then you have oxygen O here. This is what I call the perbenzoic acid, right? So we can say that these peracids that react with alkenes to form epoxide, they are gotten from the corresponding acid. They are gotten from the corresponding acid. They are gotten from the corresponding acid. All right, so let us look at the mechanism of epoxidation of alkene. That is how these alkenes are converted to epoxide. So this is this, and then you have the acid, the peroxy acid. Now we are going to use the general form of the peroxy acid, which is something like this: oxygen, and then here is carbon, double bond O, and then you have arrow. Now this is the mechanism of the reaction. If you have this as a normal carboxylic acid, peroxy acid will be what? One more oxygen, right? Which is something like this. Same applicable what we have here, RCOOH, right? So this is like hypothetical. Now, when these react, what do you think will be the product of this reaction? It's very easy. First of all, this double bond here will break, come to this oxygen. As this double bond is breaking, coming to this oxygen, this one will also come here, right? This one is coming here. This bond will break here to come and form a linkage here. Is that okay? Now this is going to form an intermediate. The intermediate is something like this. this is C, carbon, double bond C, right? Then you have this and this, then you have this and this. Now these have 1, 2, 3 double bond here, then you have something like this, and then you have something like this, then you have oxygen in the middle, and then all these bonds here, they are telling you that these things are capable of breaking down or breaking. So you have something like this, then finally this oxygen here, this arrow, and then that this is a carbon atom here. This is like the intermediate that is formed, but at the end of the day, not really concerns you with the intermediate. The intermediate is just telling us that, okay, when this one joined with this, what did we form? Recall that this bond is coming here, so there will be a linkage between this carbon and this oxygen. This one is also coming here, so there will be a linkage between this carbon here and this oxygen. That is what we have here. And then since these ones are coming here, this group here also, forgot to write this one, this group here will also pack here, and as it's coming here, that is where you now have the linkage between this oxygen and this hydrogen here. Are you getting it now? This bond here is broken. That is why you have it as broken wedge, because this one is leaving here, that bond is no longer there. So at the end of the day, what do you think will be the product of this reaction? It's very easy. You now form your epoxide, which is something like this: C, hydrogen, then you have C, hydrogen, double bond O, double bond this, plus your acid, which is C, arrow, and then here would be double bond oxygen, and then you have O and H. So this is an alkene. This is a peracid. This is the intermediate, like the transition state, and then this is the epoxide, and this is the acid that is formed. But in most cases, I don't think you will be given reaction mechanism to write, right? You may not be given reaction mechanism to write. Just know the product that will be formed when alkene react with peracid. It usually form an epoxide and the corresponding carboxylic acid. All right, it formed the epoxide and the corresponding carboxylic acid. All right, so how we learn this? Let us write the mechanism for the epoxidation of peroxy acid of propene. Supposed to be mechanism for epoxidation of propene by peroxy acid. It's still the same thing. Propene is something like this. You have double bond, you have H3C, you have hydrogen, right? Now you have peroxyacetic acid. Peroxyacetic acid is, if you want to write it out first, C double bond O, then we have OOH, right? Which we can arrange as oxygen, which is this oxygen, and then we have hydrogen here. Then after this oxygen and hydrogen, what do we have again? We have oxygen, right? After that, what do we have again? We have carbon, which is this carbon. Then we have double bond what? Oxygen, and then we have the CH3, which is this. So I can wipe this off. Now when this react, I told you that it's movement of arrows. Arrows are being moved, bonds are being moved. So first of all, we said this one will firstly come to this position, right? And this one is coming to this position. What do you think is going to happen? This bond here will pack here. As this bond is packing there, this one is coming here. This one is coming to meet this hydrogen. You just need to practice how each of these bonds they move, and you are done writing the reaction mechanism. It's very easy since it is a consacted mechanism. Is what type of mechanism? Consacted. Consacted means it takes just one step. Everything you discover here will took just one step to arrive at them. So the product of this reaction will be something like this. You have this, the double bond will no longer be there, so you have carbon, you have hydrogen, hydrogen, here is CH3, here is hydrogen, and then you have oxygen, oxygen, which is the epoxide. So this is the epoxide that is formed, plus acetic acid. Acetic acid that will be formed in this case will be something like this. You know, this one come here, so there will be a double bond. This bond is the one that came here, so there will be a double bond here. So you have C, double bond, oxygen. Then this bond came here, so there will be just a single bond here because one of the bond here came here. So you have oxygen here, right? Now this bond bonded with hydrogen here, so you have the linkage with hydrogen and then CH3. And this is the structure of acetic acid, which you can also write as, you can write it as CH3, C double bond O, OH, CH3, C double bond O, OH, which is this. So this is the mechanism for the epoxidation of propane by peroxyacetic acid. Now the stereochemistry. Now because epoxidation takes place using a contracted mechanism, it retains the configuration of the alkene because there is no opportunity for the alkene to rotate and change its cis or trans geometry. The epoxide retains whatsoever stereochemistry is present in the alkene. If the alkene is a trans alkene, the epoxide will also be a trans epoxide, right? Same thing applicable to the one we did on glycol, cis glycol and syn glycol and the rest. So having learned this, let us use this to work. Predict the product of epoxidation of the following. Now, one of the epoxidation reagents, let me take it like that, or one of the peracid that is mostly sold to be used for epoxidation is this. Now, what is the meaning of this MCPBA? It means meta, that means at meta position, right? Meta chloro means at the meta position there is chloro group there. Meta chloro. Then you have, what is this meta chloro? Okay, P means what? Pa benzoic acid. Metachlorobenzoic acid, or you can also call it M-chloroperoxy, right? Benzoic acid. Now this is an epoxidation agent or epoxidizing reagent. Now same way we have another one which is called magnesium monoperoxy phthalate. Magnesium monoperoxy phthalate. You can go check on this MMPP. These are both oxidizing agent, epoxidizing agent. So these are the commercially available epoxidizing agent. So if you want to get an epoxidizing agent, and let's say you want to epoxide an alkene or make an alkene to undergo epoxidation reaction, you go to the market and tell the shop that you want to get M-chloroperoxybenzoic acid, or you can say MCBA or MMPP, which is magnesium monoperoxy phthalate. If you go to the industry, all these are present there for that epoxidation reaction. So at the end of the day, let us predict the mechanism. We are not going to predict the mechanism, we are just going to predict the product, since you already know how to write the mechanism of epoxidation reaction. So what do you think will be the product of this reaction? It's very easy. We said it will take the stereochemistry, so this will be C, and here will be what? CH3, here will be hydrogen, here is hydrogen, here is CH3, and then here is double bond oxygen, right? Plus the M-chloroperobenzoic acid. But now, since we are now talking about the product. What will be there is just M-chlorobenzoic acid, because one oxygen has been used to oxidize or epoxidize the alkene. So we will not be having 2 O here, but just 1 O. So this gives us this structure, which is like one of the product of this reaction. So we have chloro, C double bond O, and then you have OH. Are you getting that? So this is the epoxide that is formed, and then this is the acid that is formed. So whenever an alkene reacts with a peroxy acid, or you can call it peracid, peroxy acid, or the peracid, the product that is formed is the epoxide and then the acid. Now, same thing applicable here. This one is just trying to tell you, or just trying to make you understand that stereochemistry matters here. Since this alkene is a cis alkene, it has these 2 groups here. It's going to give a cis product too. However, this is a trans alkene, so we are expected to have a trans product, and that will be something like this. So this will give us C. Of course, we have double bond oxygen, right? And then we have CH3. We have hydrogen. We have CH3, and then we have hydrogen, right? So this is the trans form of it. So it must always retain the trans configuration. If the initial alkene was trans, and the cis configuration if the initial alkene was cis. So this is the product of this reaction. There you have something like this, and then you have C double bond O and OH, which is the M-chlorobenzoic acid. So I can come here and say this is M-chlorobenzoic acid, right? Kinda very easy. So that is that for epoxidation reaction. Now you have another question to work on. Predict the product of reaction between but2-ene and peracid or peracetic acid. But2-ene is something like this. Let's say you have C. Okay, if you are saying but2-ene, let's use the cis form of it first. So this is cis but2-ene. And peracetic acid. Peracetic acid is something like this: CH3, C double bond O, OOH. So what do you think will be the product of this reaction? Of course, is predict. They said we should predict. This is going to give us an epoxide where you have, this is C, CH3, C, O, C, this, and then here is also CH3H, which is the cis epoxide, since the initial alkane was the cis form. So this is the epoxide, plus the other product that will be formed would be acetic acid, which is CH3, C double bond O, OH, right? And that is acetic acid. Is that okay? That is acetic acid, and that is the product of this reaction. It's pretty very easy. Now some of you may want to ask, why is it that this guy, when he wants to write for alkene, like he wants to write reaction, why did I write but2-ene like this? Why didn't I just write the but2-ene as CH3, CH double bond CH3? Now if you write this as but2-ene, is correct, but the reason why I have to bring it out like this is so that we can actually have a space to react with the double bond, because we said that the part of the alkene that reaction takes place is the double bond. All right, the double bond. So that is practically that. All right, Now let us look at some of the reactions of epoxide. Before we talk about some of the reactions of epoxide, let's look at other methods for epoxidation apart from that of the peracid. Other method of epoxidation apart from that of the peracid. Now, hydrogen peroxide, this is supposed to be hydrogen peroxide, not just H2O. This is supposed to be hydrogen peroxide. When you have hydrogen peroxide with sodium hydroxide, the product of the reaction is CH3, right? There you have the CH, and there you have the CH, CH3 plus, then you now have this epoxide. This is another method for making epoxide. Same thing applicable using chromium trioxide and alcohol or acetic acid. This is acetic acid because this is acetyl group plus OH, acetic acid. This is still going to give us an epoxide. And we actually talked about this, talking about chromic acid and acetic acid, talking about oxidation of, I think, polycyclic alkene that we said is going to give us a glycol, going to give us a diol. Now the diol was actually gotten from this particular one, which is the epoxidation reaction. So this is going to give us still the same product, CH3, CH, here will be CH, here will be CH3, then you know this is the point at which it will react, and then we'll have oxygen. It's raining here, all right? But we are going to finish this episode. Now let us look at the next one. So this is another method for actually epoxidizing alkene by using hydrogen peroxide in sodium hydroxide or chromic acid in acetic acid. The next thing is, having gotten this epoxide, how do we now convert them to other alkene? Recall, when I started by saying that these epoxide, they are reaction intermediate. They are important intermediate that convert alkenes to a varieties of other functional group, right? We said they are important intermediate. So now these intermediate, how do you convert them? First of all, if you use a reducing agent like lithium aluminum trioxide, tetrahydride, lithium aluminum tetrahydride, this is a reducing agent. So when epoxide are reduction, they are going to give alcohol. So most of them are going to give the alcohol functional group, right? Or you can call them alcohol, depending on the kind of epoxide. Now in this case, they didn't actually give you the particular epoxide, but just know that any epoxide, when it reacts with lithium aluminum hydride, is going to give the corresponding alcohol, right? Now how about if you react it with OH? It's going to give us a diol, right? It's going to give us a diol. A diol is something that has, let's say, CH2, CH2, and then you have arrow. This is going to give us a trans diol, or let's say diol, trans diol, diol, whichever one, right? Now the next one is BF3. If you react it with boron trifluoride, these are mineral Lewis acid. Whenever epoxide reacts with Lewis acid, the product is usually aldehyde. It will give us a carbonyl compound, which can be any of the aldehyde. Now I told you that the product you will get depend on the nature of this epoxide, right? Depend on the nature of this epoxide. Now how about dimethyl sulfoxide? This is dimethyl sulfoxide. It's an oxidizing agent. If you react them with dimethyl sulfoxide, it's going to give us an alpha ketal. Alpha ketal is something like this. C, there you have OH, and then you have arrow. Now what do we mean by this statement? Alpha ketal means a particular ketone that has OH at the alpha carbon. Recall that this is the predominant functional group here, so this next carbon here will be alpha carbon. So a ketone that have OH at the adjacent carbon is called an alpha ketal. All right, so that is that. So it depends on the kind of epoxide. For instance, if they give you, let's say, this kind of an epoxide, let's say you have this epoxide oxygen, this H2, let's say this H and this CH3. Now if they give you this kind of epoxide and then they say react it with lithium aluminum hydride. Now you see lithium aluminum hydride is a reduction agent, so it will reduce this to form something like this CH3 CH. Now this is an alcohol. What kind of alcohol that will be formed? Is secondary alcohol, because this OH should be somewhere around here, and then you have CH, and then it continues like that, CH3. All right, so that is that for this particular one. All right, it's pretty an easy one. Just know that the epoxides will be converted to other functional group. Don't too bother about going in details to what functional group. We already talked about the various functional group they can be converted to, right? But don't go in details to talking about the product that will be formed, because I think this is where we can actually draw the curtain for this lecture. So in our next lecture, we are going to look at other aspects of the oxidation reactions of compounds. Thank you very much for your time, and bye bye.